All right, welcome to our next video in our series on Java Basics. We want to cover a few things in this video. First, we're going to talk about primitive data types. We're going to talk about different operators that you can use in Java. We want to talk about a special operator called modulus that's pretty interesting. And we want to talk about some operations that can be dangerous, namely integer division and double division. So that's the objective of this particular video. Let's start with primitive data types. So if you watched the previous video, you know we can write a Java program whose job it is to print things to the screen, and that's useful, but it's not going to get us very far. Ultimately, we need to be able to store values in our code. We need to be able to set aside a number, a word, some letters, a true-false value, so that we can refer to them later in our program. And if you think about the apps that you use, the video games that you play, there is stored information all across them. Well, the names for where we store these variables is called, these pieces of information is called variables. And when you store a variable, Java is a typed language. Java is going to ask you for what type you're using. And there are 8 primitive data types in Java. In our experience, we're going to use 4 of them. The 4 primitive data types are, we have int, which stands for integer. We have double, which is basically a decimal number. Decimal number. We have char, which stands for character. Some people like to call it char. I think those people are silly, but that's fine. I know it's not character. It just looks like char. So I guess that's just me. And then boolean, which stands for a true-false value, named after a famous logician, George Boole. This is where we get the term boolean. So these are our primary data types. And we can operate on these data types the way that you have been in your math classes, right? So we have the plus sign, gives us addition. We have the subtraction sign, gives us subtraction. We have multiplication, which is, we use the star for that. The nickname for that is called splat. It's called the splat. And then the / represents our division. Very good. By the way, if you don't recognize the code, the reason that it's gray right here is because I'm using these 2 little /. What I'm communicating to Java is, hey, don't execute this code right here. It's called a comment. And we can specify a comment by using // makes a comment. We can also use / hello world. And that would be a multi-line comment. We could have multiple lines of comments if we wanted to do it that way. Okay. So we have the 4 primary primitive data types that we're going to use. We have 4 types of mathematical operations that we use, and we can use these to print some values out to the screen. So maybe I say system.println, and I want to know, hey, what is 3 times 10? And I just think it's a nice thing to put spaces before and after your operations. It reads a little bit better. If you squish everything together, it's going to start to look gross after a while. So don't do that. We remember Control K is the compiler hotkey. I head up to my file. I ask for the main method. And sure enough, 30 is what's printed out. Great, that looks good. By the way, when you code, I do recommend setting up your screen so that you have maximum vertical height for your code. You can see your files and you can see the console. I just think that's cleaner than having to bounce between screens constantly. So we can do 3 times 5. I could do 20 divided by 4. And that's going to give me what you would expect, which is 5. I could do 13,857 minus 982. And because we're working with a super overpowered calculator, ta-da, it tells me the answer is 12,875. I want to bring your attention to a new operation. It's marked with the % sign, and it's called modulus. It sounds fancy. Honestly, it's just a fancy word for remainder. And the way it works is it asks the question, after division, after you've removed as many whole numbers of your dividend? The denominator, after you've taken the denominator out, as many times as you can, what's the remainder? So if I said something like 12 mod 5, well, if we go back to elementary school, the answer to this question would have been 2 remainder 2. 5 goes in 2 times with a remainder of 2, so we would expect after compiling that this would spit out an answer of 2. How about 13 mod 5? Well, it goes in 2 times with a remainder of 3. Let's try something a little trickier. How about 21 mod 6? All right, so 6 is going to go in 3 times with a remainder of 3. Or we could pick something even trickier. We could say 50 mod, how about 7? Well, that'll go in 7 times with a remainder of 1. A trick that often will cause people to stumble is what happens if the number on the left is smaller than the number on the right. Well, remember what it is that we're asking. We're asking how many times does 9 fit into 5? And after you've gotten all the 9s out that you can, what was left over of your 5? Well, the answer is it goes in 0 times. And what was left? 5 was left. So whenever you see an expression where there's a smaller number mod a bigger number, you should expect to see the smaller number. Or the little nickname we use in my class is small mod big is small. That's one way to describe that. All right, so modulus means remainder. 2 other quick things we're going to talk about are integer division and double division. So you want to be careful in Java because of the way the types work. So the difference between an int and a double is that an int is an integer. Just like in mathematics, it represents any whole number that is positive or negative or 0. It includes those. Decimal numbers, you can track out to, gosh, what is it, 14, 15, feels like 16 decimal places. So it's not, a crazy amount, but you can get a lot of precision out of that. If you do math with integers, you have to get an int back. Now for addition and subtraction and multiplication, this isn't a problem, but it does become a problem for division. If I divide 10 divided by 2, I would expect the answer to be 5 because it goes in an even number of times. But what happens if I say something like 15 mod 7? Well, we know in the real world that is 2 1/7, or 2.14 approximately. But if we're in the confines of Java, if we're using ints and we have to get an int back, what's the answer? Well, if we run this, you will see the answer is 2. It has found the int that it thinks represents 15 divided by 7. So you might think to yourself, oh, I'll bet you Java's just rounding. And you're almost correct. Let's look at a little detail. Let's say I were to say 20 divided by, let's come up with something better. Now, let's go with, how about 10 divided by 12? Or, nope, I've changed my mind one more time. 3 divided by 4, okay. Well, in the real world, this is 0.75. And in math classes, we're taught that if you're at 0.5, you round up, and if you're below 0.5, you round down. But watch what Java does. Java says, just give me the 0. And the reason is, and the big takeaway from this moment should be, that in integer division, when you calculate your answer, the remainder is just dropped. The decimal is essentially cut off of the number. So even if I say something crazy like 99 divided by 100, we know that should be 0.99. But because it never gets to 1, it's treated like a 0. Or even if I said, 399, that should be 3.99. But when I go to calculate it, it's just going to give me 3. So when it comes to integer division, be wary that the decimal is going to be dropped off. Okay, the last thing I want to point out is that although computers are very powerful, they can give us a lot of useful information. Double division is also something that we need to be aware of. So when you look at dividing 2 doubles, if I pick something like 1.0 divided by 2.0, then you should get what you expect, 0.5. If I pick another thing that is easy to represent, how about 3/8? Right, so that's going to be, 0.125 times 3, which turns out to be 0.375. That sounds good. But watch this one. What happens if I say 5.0 divided by 3.0. And the reason that Java knows the type I'm using is because I'm including the decimal. If I had taken out the decimal, Java would assume I'm working with ints. But because I include the decimal, Java knows I'm working with doubles. I compile this, I run this, and we get 1.66666. Oh, 7. Well, this is great. So Java has given us the correct answer here. The danger with double division is that sometimes when Java goes to run this final digit, it can come up with an error. So we want to be cautious of when this might happen. Let me try another one and see if I can get it to appear. All right. So 1.333333. No, that one looks correct. How about 1. Let's try another one. 7/3. Will this do it? Ah, there it is. We found it. So normally you would think if you wanted to come up with a decimal that represents 7/3, that you would just go 0.33333 onto the end. But here we see that Java has failed to calculate that last digit correctly. It should be 3, and it has kind of had a hiccup and it's come to be 5. Later in our projects, we're going to be on the lookout for double errors, and we're going to come up with some techniques that help us to detect when they've happened and make sure that they don't cause bugs in our code. Okay, so that is primitive data types, operators, modulus, int division, double division. The last thing we're going to cover is just what is the notation for all of these types. If you're working with a type, what does it look like? And an example that I enjoy giving in class is I will say that the values 3, 3, 3, and 3 are all different. Yes, they all represent the quantity 3, but their types are all different. And it's because I used different notation with each of these that we can figure out what's going on. 3 by itself, that's an int. It represents a whole integer, right? 3.0, that's going to represent a double. 3 with the single quotes around it, this is going to be a char, meaning it represents a single character. And 3 with the double quotes around it, that's going to be a string. Notice that string is capitalized, and that's to reflect the fact that strings are not primitive. They are complex. They can perform operations for us. They have methods. They do lots of great things. And so we'll see why, even though you're going to work with strings a lot, they're not characterized as a primitive type. Okay, that's all I've got for today.